A doctor believes that a 4-week exercise program can reduce the resting heart rate of her patients. She takes a random sample of 7 patients and records their resting heart rate before the exercise program and again after the exercise program, and we can see all of the information in the table. Using a 5% level of significance, carry out an appropriate test of the doctor's belief. You should state your hypothesis, test statistic, and critical value. Now, I'm going to work with the difference between the two readings. And we're going to do the before take away the after. So 65 take away 63 is 2, 68 take away 65 is 3, and so on. And we'll work all the way across here, like so. And if we work out the mean for D, you'll find that it's 4, and we're going to need that value. Now let's state our hypothesis before we do anything else. The hypothesis needs to be that the mean for the difference is actually equal to 0. In other words, there is no change. Now in this case, we've done before take away after. Her hypothesis is that the heart rate after will be lower. Therefore, we're going to expect mu D to be positive because the higher values should be in this top row. So those are our hypotheses. Now going to the formula booklet, test for variance and mean when sigma is not known. This seems like an appropriate statistic which we can use with the t distribution. We don't actually know S at the moment, but we can use this, which is also from the formula booklet. S squared is an unbiased estimator of sigma squared, where S squared is given by this formula just here. So we can do that calculation. So that is going to give me that S squared is. So we just need to do each one of these individual ones, and we know that the mean is 4. So it's going to be 2 take away 4 squared. Remember, the first value of D was 2, so I'm just using those values there. The next one is 3. So we've got plus 3 take away 4 squared, and so on, working across the table until we get to the last one, which is 12 minus 4 squared. And all of that needs to be over n minus 1. There are 7 readings here, and so that's going to be 6. And if we calculate that, we get that S is 3.786, correct to 3 decimal places. And we can then use that in this formula just here. Now it's Tn minus 1, so we're looking at a T6 value, and that is going to be 4 take away 0, remember that's from our hypothesis, over 3.786 divided by root 7, because that's an n, not an n minus 1. And we can calculate that, and it gives us 2.795. We can then go to our tables. So we're wanting a T6 value for 5%. So we've got 5% here, 6 is here. This is our value. So T6 5% value, critical value, is 1.943. And we can see that 2.795 is greater than 1.943. And therefore we are in the critical region. And so what should we do? We should reject H0. And we should state that there is evidence to support doctors' belief that resting heart rate has dropped after the exercise program. And it's important that you state something along those lines. Now let's go back to part B of the question. State the assumption you have made about resting heart rates that was required to carry out the test. What we have assumed is that these differences must be normally distributed, and that's required for the t-test to be valid.